Hi, my name is Ronald Garcia, and today I'll be doing question 24.64 for the exam 2. The question says a parallel plate capacitor is made from two plates 12 centimeters on each side and 4.5 millimeters apart. Half of the space between these plates contains only air, but the other half is filled with plexiglass of dielectric constant 3.4. An 18 volts battery is connected across the plates.
The first question says, what is the capacitance of this combination? First of all, we need to know what is the expression for the capacitance of a parallel plate capacitor, which is C equal to the permittivity of the medium times the area of the plates over the distance between the parallel plate capacitors. And the expression for the capacitance of a parallel plate capacitor with dielectric is equal to C equal K, which is the dielectric constant times the permittivity of the medium times the area of the plates over the distance between the parallel plates capacitor. We also need to find the area, which is equal to length squared. Here the length is equal to 12 centimeters, which is gonna be equal to 0.0144 meters squared. Then we have to find the formula for the capacitance for the parallel plate capacitor with the dielectric material plexiglass, which is equal to the constant times the permittivity. Here we have to put A over 2 because on the problem says that the area becomes half over D, and C2 is gonna be equal to the capacitance of the parallel plate capacitor with the dielectric material air, which is gonna be equal to K2 times permittivity times area over 2 with the distance. The effective capacitance of the parallel combination for these capacitors is gonna be equal to C equal to C1 plus C2. So now we substitute everything into this formula and get 1 Q1 over 2 plus K2 permittivity A over 2 over D, and we're gonna get this formula here. And now we plug in all the numbers of the values. Plus 1, and this is gonna be equal to 6.23 times 10 to the 11. So this is the effective capacitance of this combination. So question B says how much energy is stored in the capacitor, which is given by this formula, where V is the potential difference between the plates of the capacitor. So now we substitute the values on this for this formula. C, we already got it on the previous question, and V is going to be equal to 18 volts. And this is going to be equal to 1.09 times 10 to the -8 joules. And this is gonna be the answer for this question, and this is the energy stored in the capacitor. The last question says, if we remove the plexiglass but change nothing else, how much energy will be stored in the capacitor? Okay, if we remove the plexiglass, then the total space is filled with air, and then the capacitance is going to be equal to this: A over 2D plus the constant 2. We now use constant 2 and constant 2 again because we are using the constant for the air, and this is going to be equal to 2, and cancel this out, and we're gonna end up with 40 times k over 2. Then we plug in all the values for this formula. And the result for this one will be 2.832 times 10 to the -11. So now the corresponding energy stored is given by this formula. Now we substitute the values into this formula again. We plug in the new value that we got here times the same voltage potential, and our last result will be this one: 0.4588 times 10 to the -8 joules. Now the change in the energy stored is given by this formula: the energy final minus the energy initial. And now we substitute these values, the one that we got in question 2 minus the one that we got here, and this is gonna be equal to 5.5 times 10 to the -9 joules. And this is our answer, and this is the energy stored in the capacitor.